So hello everyone, welcome to my video. This is just a preview of AI-based fraud management system, and I this project is in development phase, and this is just a blueprint that I have made, and in which we will be discussing the AI, the general knowledge of AI, for both technical and non-technical audience, and the approach that I have, applied to till now to reach the goal to implement this fraud management system via AI, or also we can say deep learning. Deep learning is a AI is a part of deep learning, and some people used to say deep learning as well to AI. Let's get started. As you all know that I have earlier made FM system with live alert generation. I will show you in video quickly, and then we will move ahead. Okay. So uh, earlier I have made the FM system with Python and SQL, and I have explained that in earlier video, which is available in YouTube. You can see here in Outlook the alerts are coming. This is the first rule: summarize destination calling alert, and the records are there in the email body as well. I have automated the Python script, and the database is in SQL, and the alerts are being generated as per the rule formation. The second alert is their calling usage alert. Mainly three usage alerts were there, and one overlapping calls mechanism in which one call has not ended, another call started. So these four alerts also I have showed through Gmail. Also, you can see here. Yeah. Okay. That's I believe it's covers the preview. So back to our AI based fraud management system. So the first thing is, we will learn about the AI and why AI is evolved. So there are limitations of machine learning. As you can see in the presentation window, the slide is saying that it is not useful while working with high dimensional data. That is where we have large number of inputs and outputs. So if I say in layman terms, so if the number of columns are more, like much more, so it will be problematic for ML to analyze and and to process. You can say that in complications in term of speed, because n number of columns are there, 1000 columns are there, and then the feature selection becomes impossible, becomes difficult, because it is manual in machine learning, feature engineering and feature extraction. So this create problems. And even for example, I will tell you that feature selection is like any image in garden. If you are in garden, suppose, and you can think how many features will be there, like pets, trees, plants, and other things as well, other people, and some uh, some other things as well. So in that image, automated feature engineering is required. So this should not. This is not in machine learning. And also you can see in slide, NLP, natural language processing, and with in that ML is also problematic. Okay, we will now move to next slide. Okay, so deep learning or AI, yeah, what is it? So the idea behind deep learning is to build learning algorithms that mimic brain. So you can say that AI or deep learning is to mimic the functioning or working of brain. It is made in such a way, uh, a natural way, that how brain works. I will clarify more if we go to next slide. Okay, so As we all know, in biological term, the smallest unit of the brain is neuron. You can see in the presentation window also, neuron is there. And you can see a lot of sensor in neuron. Here, if I revolve the mouse, you can see here neuron is written over with the red pen. So yeah, so what does neurons do? Firstly, you can see here in the outer part, there are input sensors called dendrites. Okay, so dendrites, they capture stimuli. So stimuli, you can set it to data. It can, in computer term, we can call it data, and they forward this data to the nucleus. Okay, so nucleus has two working. Firstly, what is coming, what are all inputs are coming, sum of all inputs, sum it up, and then process it accordingly. And you can see in the last in this nucleus image, there are axion terminals, and axion terminals as our output, nodes, you can say, and they take action. And this all request and response happens through neurons. There are n number of neurons there. For a natural, example, I can say, if you somehow you are going through any road or in park, and suddenly you put your barefoot in the, some edgy thing or a screw. So immediately what will happen, you will feel pain, and suddenly your brain will pull out your barefoot from that screw or edgy thing in your way to save, because the brain is trained in such a way. So similar simulation has been provided for AI models as well. So I will tell you from scratch now. If I told you that the smallest unit is of brain is neuron, in technical term or computer term, it is perceptron. You can see in the presentation window. Sorry, in the this one, in the red pen, perceptron is there. Okay. Similarly to dendrite, which is the first sensors to observe pain or anything sensation, anything touch with our hands or with our body. So that is the same thing with here in perceptron x1, x2 up to xn. They are neurons. So neurons are the first layer to you know put data into the system. So after that, when system has been input data has been processed by the neurons, then it went to the nucleus. And what nucleus has two functions. What one is integration and another one is activation function. Integration, whatever data is coming, they had to sum of all data, they have to sum the data, and then activation function will process it for further results. We can move down to next slide. Okay, so I will be explaining this equation, which is the equation of AI and deep learning. Okay, let me explain. So yeah, so we can see on this slide, equation of a straight line y is equal to mx plus c, as we all know. So who don't know, I will quickly brief you. Uh, Actually, we have to understand by going to school maths. So quickly visualize that, I believe in class ninth in India, they tell about this one. So this is the graph, we all know, and visualize that, the teacher gave us this question, that equation is 3x minus y is equal to minus 3, and you have to find the x and y coordinates. So we all know, as you can see on the first line, we all know the equation of the straight line is y is equal to mx plus c. Okay, so let's go. And c is the constant. Also, c is the intercept where y has been intercepted. Okay, so we have given the equation 3x minus y is equal to minus 3. Let's see here in blue pen I have written. Firstly, we have to evaluate this equation 3x minus y is equal to minus 3. Then adding 3 on both sides. So this side minus 3 will be cut by the plus 3. So what we got, y is equal to 3x plus 3. Y will come here, it will become positive, and 3x plus 3 is already here. So you can see here also simplifies as y is equal to 3x plus 3. Now we all know y is equal to mx plus c is the equation. So we got m and we got c. So we will start from c. As we know, c is the constant and the intercept, where the point where the line cuts the y-axis. So this is the red line we have to draw. Just visualize that we got the point 3. So 3 is this point. This is our first point. I have also showed it like c is here. So this is our first line. C is equal to 3, and then m is 3. Y is equal to 3x plus 3. So m becomes 3. We have to come, as m is positive, we have to come one step ahead of that c, the point we got, and then we have to go 3, because m is 3. 1, 2, 3 above. Here, from here we have to draw this line which is in red, and we have to go further till it cuts the x-axis like this. It is going right. So now we know where it cut the x. This is minus 1. So we got our coordinates. X is equal to minus 1 and y is equal to 3. So this is all. I believe this is a good example of school maths. I also, somehow was able to understand, convey it to. So okay, so now I explained the equation of a straight line y is equal to mx plus c. It will change here. I will tell you how. So let's start. So you can see here I have three neurons, uh, x1, x2, and x3. This is the input layer. As I told you, these are three, x1, x2, x3, and these are called input nodes. So why I have taken three neurons? Because in my input data there are only three features: x1, x2, x3. I mean, three columns are there. It can be anything: calls, time duration, and call number. So that's why I have taken three, for example. So these neurons will act as dendrites, providing data information to nucleus. So this green one is nucleus. So you can see here in nucleus there is one integration function, and I already told you there is another function, activation function. So the integration function, it will collect the information from input nodes, okay, from x1, x2, x3, and the activation function has to process the data and give output. You can see in the last red circle y cap. This is the predicted value. So equation of a straight line, as I told you, y is equal to mx plus c. So we got our x1, x2, x3. You know, y is equal to mx plus c. So x are the factors for single factor. This is x, but we have different three factors: x1, x2, x3. I mean three columns. So that's why x1, x2, x3 are our. We got our x. So for AI, M is deep learning. M is uh, W weights. Weights are W1, W2, W3 accordingly. So M become W1, W2, W3. And for C constant, we have to add. You can see here in the end. One more yellow circle is there, and we have added one more neuron for the value of c, whose weight we have given as b. So, and the value we for this neuron x naught we have given 1. Okay, so that's why now you can see that um, what activation function will do, integration function will do, will sum up w1 into x1, w2 into x2, w3 into x3, and we will sum this. So the equation will become like this only. You can see here y is equal to w1 x1, w2 x2, w2 x3. As x naught is 1, so b into 1 is equal to b, so plus b. So the whole equation will become lastly y is equal to w1 x1 plus w2 x2 plus w3 x3 plus b. We have added this one more neuron x naught is x naught with a value of 1 and weight as b, so that our this artificial neuron, that is perceptron, can solve our linear problem. So this is the whole equation that I have explained till now. We will go further now. Okay, so yeah, I have already explained the equation for deep learning. Y is equal to wx plus c when our parameter is single, that is x. When we have more than one parameter x1, x2, x3, the equation y is equal to w1 x1 plus w2 x2 plus w3 x3 plus b will apply. Now we will move to next slide. Okay. So here in AI, there are two type of networks, ANN and CNN. We will be using ANN in our model. CNN is basically for images, image recognition. I will tell you how it works. You can see in presentation window in this slide. There is one is X, one is O. So it has to recognize X and O. So if somebody gives the handwritten X and O, so the system has to analyze and correctly and gives X is equal to X and O is equal to O. That what the right now image is depicting. Okay, so this is not a magic. We have to train the model in such way that it will recognize if it is X or it is O. So you can see here a computer understand an image using numbers at each pixels. So what we have done, the the x-axis, you can see all are positive ones. The number one is there, but they are all positive, and the space where it is empty, the pixels there is -1. So the black pixel is value 1 and the white pixel has value -1. So if you write in page in a blank paper and put that in system, it will easily recognize because it will firstly divide the page into pixels, the whole image, firstly the whole image, then it will use filters to where is the black part and where is the white part. I mean, where okay, then it will judge the part where the positive ones are there, and according to the algorithm, it will judge whether it is X or what, either it is O. So yes, we will move down to next slide now. So in the context of this training, that part that I have just told you for images, what I have planned, that my approach is that I will give some fraud patterns, as you can see in the slide, that there's some call records I will provide of every fraud alerts, like majorly four fraud alerts are there that I have made in system. So system will analyze the records. Wait a second, I will tell you. So yes, I already told you. There are two things: fraud patterns and fraud labels. So under fraud patterns, there were call records which are fraudulent, and we will train the system in such way that it will categorize the fraud records, I mean patterns, into the corresponding fraud labels. So let's move on to next slide. Okay. So yeah, this is the main blueprint that I propose and I am working on. That we will make a AI based response system. And what are the feature of this response system? You can see here in presentation window. You can We respond to alerts. I told you there are basically and only four alerts. And what will happen whenever the alert will be made, and then system analyze sub alert with details will be generated by artificial intelligence, and it will also cover fraud score. So what happen, it will assist the on duty analyst with the recommendation. It will analyze the alert. I already told you that is made by rules and generated by the Python script that is going on. and it will analyze the artificial intelligence system, AI system will analyze that alert, and then will give the recommendation also, and it will help analysts to reduce the workload up to 70%. 70%, because I will tell you how. Because the alert will do fraud analysis, and also good give fraud probability, and you can see that it will also assist on the critical fraud scenario. That is the second part. But if some alert solution will come and it will say that this is fraud, and this much percentage of fraud is there, so it will help analysts to understand that what is the other checks. Already if the if the system generated alert is saying that it has a probability of 90%, so that is the case that it has to the analyst has to check few more checks, whether the customer has a calling history of to this country, or the customer is a national of this country or not. So if not, and if other checks also provide a good analysis, then they can escalate to further a team that it is a fraud alert, and take the action accordingly. And also the third one is that will assist on critical fraud scenario, and will take action on behalf of analyst. So there are I told you some parallel callings and international calls with context to that is a very high fraud scenario. So some actions, the automated actions that we will give, we will told system to take, the system will take it on behalf of uh, human touch. Okay, so let's move to next slide. And this is phase two. I have proposed a hybrid model in which unsupervised machine learning. You can see unsupervised machine learning can be applied, and the module of the unsupervised machine learning is clustering. So what clustering is? It is divide by similarity. I will just quickly give you an overview that if some overlapping calls, I mean there are a n number of call record, but it will take the similarity between the two records. So if the data or we can say call records have similarity, like I have shown here, call record 1 and 2 have similarity, then it will put it under one cluster, like this cluster 1, and another call 3 and call 4 in under cluster 2, and then it will check for the category, and it will come under the category of overlapping calls, so it will make the cluster 1 for overlapping calls, and other call 3 and call record 4 come under summarized destination calling usage, it will make another cluster of them. So this is a very good thing, hybrid model, in which some rules we have applied and taught the artificial intelligence to caught the frauds. But in this, the system will judge the normal calling pattern if it is around about 90%, and between the similar calling pattern and dissimilar calling pattern. So fraud is dissimilar. It will analyze the whole records, I mean to say 100% of all the call records, and 90% calling is legitimate. Then it can caught the 10% dissimilar call records and categorize into clusters according to the fraud patterns. If the short calls are there, so there is one cluster. If the long calls are there to the high risk destination, then another cluster is there. So like this only. Okay, so this ends the slide, and now I will show you uh, the code I have designed for AI, and the part that that will be that is developing through AI. But I will show you how it look like as a output. Okay. Okay, so here are we, and I will show now what will be it will look like when AI will take action. So I will run the code now. Okay, so I will run the code. Just wait and watch. Okay, so the code is running, and if we can go to the mailbox. Okay, so mailbox is here, and you can see, what has done. what happened is, what a beauty. Wow. This is the main alert you can see in the window right now. Summarize destination calling alert. This is the main alert. And what AI has done, it has analyzed and generated a self-made alert. You can see fraud alert above of summarize destination alert. There is a fraud alert P1, priority 1, AI generated. Okay. So wow, what a beauty. And because these are the scenarios, that AI system has been trained on. So let check the main alert first. Okay, so yeah, this is the main alert. Even I have modified the code in such a way that it is generating the analysis. Dear user, in this alert, earlier it was not there. You can now I will read. Dear user, in this alert, four calls are made towards Cuba and with a total of 423 minutes. Here are the details of all records. I mean, earlier only this I showed you in the starting of this video that only these records were there. But when system AI will take, I will train in such a way they would alert will come like this, the main alert, in which everything will be written only, written also. Four calls made, total of 423 minutes. Okay, so this is the main alert. So yeah, now we will see the AI generated alert. This one, the code I have written. Oh, wow, whatever do you can see here, three alerts have been there because the subject is line is same, so it come under, yeah. So you can see, dear user, fraud alert. The number this one ending with 75468 has exceeded 100 minutes in a single day. There is 90% chance of fraud. Here are the details of the records. You can see the number ending with 75468 is here. It has exceeded 100 minutes, over 100. That's why AI has generated this fraud alert. So similarly, you can see 24 minutes. So three numbers are there for all three. Have the AI has generated the sub alerts. You can see the number ending with 324328 is also there. Here is one, and the last one also 324728. This one also 122 minutes. All three. There is 90% chance of fraud. Here are the details of all the records. So I told these are the scenarios that AI system has been trained on. So for main alerts, and what a beauty, the code I designed and it has done the analysis, to which a human analyst can take around 5 minutes, but the code is doing it in a split second. Can you believe it? This is the power of human intelligence. And now when AI will learn this, it will also take split second to judge between fraud and non-fraud. Okay. So this is the scenario for this one. And now let's see another example that is more critical of overlapping calls, in which one call has not ended but another call has started, which happens in PBX hacking, generally. So let's watch this. I will just run the code now in front of you. It's all live and see what happens. Okay, so the code is running. Let's wait here in the email window. Okay. Oh, wow, what a beauty. The main alert has been come for overlapping calls usage alert. Okay, we will see and we will check it. Okay, so I told there are two CDRs, previous CDRs, which is saying 524 calls started, 548 ended, and next call started. You can see 538. The call ended in 548. In between the second call has started. So this is the main alert which AI has generated, and the fraud alert also generated. But let me show you. Yeah, the fraud alert also. So if I open this fraud alert now, you can see this one comes under the this one, dear user, fraud alert. The number this one has been found in an overlapping call scenario to Angola. See, this this subject line is automatic. This email body briefing analysis is automatically generated. It has already automatically read the destination name Angola and put it here. So has been found in overlapping or parallel call scenario to Angola. There is a 99.99% chance of fraud. Also, for precaution, outgoing calls have been barred by sending barring commands, and a message had been sent to the mobile number to contact customer care on this. Here are the detail of the records. So what a beauty! You can see the system has analyzed and generated, AI based fraud alert on the same number, so that, if the you can see here in the subject line, fraud alert P1 AI generated. When this alert will come, the system, the analyst will have to do nothing, just quickly go and open this, and you can just follow the steps, because system is already analyzed. I told you 70% of work has been done by the AI. So this is the beauty of this thing. So yeah, so I told you how now the functioning of this AI, and I will now incorporate this into the neural network and artificial, and create artificial neural network, which will take the decisions, and on certain, fraud patterns that I will train them. They will do like this only. So guys, I have, explained this video from beginning till now, in briefly, because, I want to give perspective to both technical and non-technical audience to understand AI and what I am doing right now and what output is right. You can see, you have already seen. So I told you that, ML takes time, but AI is very fast, very quick, and the future is AI. So this is Akhil Singh Rawat. I hope that I have conveyed you this AI perspective and blueprint and functioning as well. And very soon I will made this AI based fraud management system, and will show you the live functioning of it. So take care. Bye bye. Have a nice day. All right.